Right, 21, solving by factoring. We first need to get everything on one side of the equal sign set equal to 0. To do that, I would move this negative 5 to the other side, and I would do that by adding 5. So that leaves me with x squared minus 2x minus 15 equals 0. So then I have my a, b, and c. A is 1, b is negative 2, c is negative 15, and ac is negative 15. So now I need two numbers that multiply to negative 15, but add up to negative 2. So that would be negative 5 and 3. So negative 5 plus 3 is negative 2. So now I'll have x minus 5 times x plus 3, which that's still set equal to 0. So set both of these factors equal to 0, meaning that x minus 5 equals 0, x plus 3 equals 0, and solve for x by adding 5 here, subtracting 3 here. I'll have x equals 5 and x equals negative 3 for number 21. For number 22, I need to have everything on one side set equal to 0. So subtract 4x here, subtract 3 here. So I'll have 4x squared minus 4x minus 3 equals 0. So a is 4, b is negative 4, c is negative 3, and a times c is negative 12. So negative 12 is ac, b is negative 4. So I need numbers that multiply to negative 12 but add up to negative 4. So negative 6 plus 2 multiplies to negative 12 but adds up to negative 4. So then I'll have to rewrite this. So take out the negative 4x and replace it with negative 6x plus 2x minus 3. So then I put parentheses around the first two and second two terms. Take out the GCF of these two, and I'll have 2x. The GCF of these two is just 1, but notice how these are the same. When we factor by grouping, it should be. So then I take out that GCF of 2x minus 3, and that is multiplied to 2x plus 1. When I take out 2x minus 3 from here, I have 2x. Take out 2x minus 3 from here, I'm left with 1. But now I have to set all that equal to 0. So I set each factor equal to 0. 2x plus 1 equals 0, and 2x minus 3 equals 0. Subtract 1 from both sides and divide by 2. I'll have negative 1/2. Add 3 to both sides and divide by 2. I'll have positive 3 over 2. So my answers are going to be negative 1/2 and 3 over 2 for number 22. Number 27, it is asking you to use the quadratic formula to solve the equations and to write it in both radical and decimal form. So this is the quadratic formula. So we have a equaling 2, b equaling negative 1, and c equaling negative 2. So we need to substitute all of that in for a, b, and c in the formula. So let's do that. Again, negative 1 is b, 2 is a, and negative 2 is c. So going from here, we have negative 1 times negative 1 is positive 1. Negative 1 squared is positive 1. Negative 4 times 2 is negative 8, times negative 2 is positive 16. So we have positive 1 plus or minus the square root of 1 plus 16, and 2 times 2 is 4. So now we have 1 plus 16 is 17. And 1 plus or minus the square root of 17 over 4 can be rewritten as 1 minus square root of 17 over 4, and 1 plus square root of 17 over 4, and that's it in radical form. As decimals, you'll get 1.28 and negative 0.78. Okay, so those are your two ways of writing that. Number 28, we are again using the quadratic formula. So substituting in a, b, and c. C is negative 1/3, b is 4, and a is negative 6. So simplifying that, we'll get negative 4 plus or minus a squared is 16. Negative 4 times negative 6 times negative 1/3. Negative 4 times negative 6 is 24. Times negative 1/3 is negative 24 over 8, which is negative 8. So then 16 minus 8 is 8. So then negative 4 plus or minus square root of 8 over negative 12 becomes, we can simplify the radical 8 to 2 radical 2, and then we have a GCF of 2, which become, if you divide 2 by each of the numbers in front, we'll have negative 2 plus or minus radical 2 all over negative 6, which can then be split up into and simplified, because these are both negatives, as 2 plus radical 2 over 6, or 2 minus radical 2 over 6, and as decimals, that's 0.6 or 0.1. That's number 28. 29, we are solving a system. So what we will do on this one is make one of the variables the same but different signs. So what I would do, looking at this, is make this y a positive 2, since this is a negative 2y down here, to eliminate my y's. So multiplying everything up top by 2 will give me that 2y. So I'll be 2x plus 2y plus 24. 12 times 2 is 24. Now I'll add 2x plus 2x is 4x. 24 plus 10 is 34. Divide both sides by 4. I'll have x equaling 34 over 4, which reduces to 17 over 2. Okay, so I now have x. I need to find y. So I'm going to substitute in 17 over 2 for x, because it equals x. So then I subtract 12 and 17 over 2, and I get 7 over 2. So my solutions, my ordered pair, would be 17 over 2 and 7 over 2 for my answer. So let's look at 31. So now this system I'm going to solve by substitution. Since I have a variable already solved for, I'll substitute in this for x. So I replace x with negative 4y plus 2. I distribute to 3, and I get negative 12y plus 6 plus 2y equals 11. Combine my like terms of negative 12y and 2y, I get negative 10y plus 6 equals 11. Subtract 6 on both sides, I get 5. So negative 10y equals 5. Divide both sides by negative 10, I get y equals negative 1/2. When I reduce 5 over negative 10. So now I need to substitute this in for y. I'll do that in the first equation. So negative 4 times negative 1/2 is positive 2. 2 plus 2 is 4. So my ordered pair is going to be 4 and negative 1 over 2 for my answer. For 32, the senior classes at high school A and B planned separate trips to the indoor climbing gym. The senior class at high school A rented and filled 3 vans and 2 buses with 133 students. High school B rented and filled 13 vans and 7 buses with 483 students. Every van had the same number of students in it as did the buses. Find the number of students in each van and each bus. So the first thing we need to do is establish our variables. So I'm going to have V represent the number of students per van, and B is going to represent the number of students per bus. So looking at high school A, they filled 3 vans and 2 buses with 133 students. So it will be 3 times the number of students per van plus 2 times the amount of students per bus equals 133. So 3V plus 2B equals 133 for high school A. High school B, we have 13 vans and 7 buses with a total of 483 students. So that would be 13V plus 7B equals 483. 13 times the amount of students per van times 7 times the amount of students per bus. Okay, so now we're going to use that to find our system. Alright, so we got to make a pair of variables the same but different signs. I'm going to change the B's. I'm going to make them 14 and negative 14. So I'm going to multiply the top by negative 7 to make this negative 14. Multiply this by 2 to make it positive 14. So multiplying negative 7 times 3 is negative 21. V minus 14B equals will be negative 931. At the bottom, I'll have 2 times 13V, 2 times 7B, and 2 times 483, which will be 26V plus 14B equals 966. Okay, so now I'm going to add negative 21V plus 26V is 5V equals 35 from the negative 931 and 966. So V is going to equal 7. So now what I'm going to do is to find B, substitute in 7 in for V. So 3 times 7 is 21. 21 plus 2B is 133. Subtract 21 from both sides, you get 112, which divided by 2 gives you 56. So my answer is 7 vans and 56 buses for number 32.